Today we are going to compare Telnet and SSH. Those are two other protocols. One of the purposes for comparing these protocols is to learn how to use Wireshark. Wireshark is a program that you can use to see all the network traffic that's happening on your computer. So to get started, the first thing that we actually have to do is download Wireshark. So here I am at the wireshark.org webpage. I'm going to download the 64-bit version. Every modern Windows laptop supports 64-bit. I'm going to download this just to downloads. Open it up when it's done. Yes, I want to install it. So I already have Wireshark. I'm going to uninstall the other version right now. I agree to the licensing terms. So what do I want to install? All the defaults are fine. Don't need to change anything. Click Next. So you can choose, do you want the start menu icon? Yeah. I don't want a quick launch icon. Everything else is fine. Install it to the default location. Wireshark is fine. Now here's a critical piece. Wireshark needs access to capture data on your computer. You have to install WinPCAP. If you don't have WinPCAP installed, you have to check the box to install WinPCAP. That's Windows Packet Capture. This is essentially the driver, what works with your network card to actually capture all these packets. So if you don't have it installed, check it to install it. If it's not working, go through the Wireshark install it again. You have to have it there. I'm going to leave it unselected just because I already have it. I don't have USB packet capture. If you're going to use a special USB network adapter to capture packets instead of the wireless card in your computer or the network card, wired network card, if you have a special USB network adapter that you want to use to capture, you would need to install this. I don't think anyone's going to use it. You can always install it later if you have to, so I'm going to leave that unchecked. Click Install. It should go fairly quickly. So when this finishes, if you've installed it the first time and you try capturing packets and nothing really works, sometimes it's just good to reboot your computer because this does install some stuff that interacts at the very low level operating system level. So it's just can solve some basic problems, right? First step of troubleshooting computers. If it doesn't work, reboot. So I'm going to run Wireshark. I don't need my web browser anymore. Okay, so Wireshark is up and running. That's good. I'm going to resize it so it fits a little bit better in my window. You should also have PuTTY. You should have had this on your computer for a long time. So I'll assume that you've got PuTTY up and running. So I've got both programs here. I'll see if I can run them at the same time in the same window. Okay, we've got Wireshark, we've got PuTTY running, so I'm good to go. So I should be able to connect to a remote system using Telnet and SSH, explain the difference between Telnet and SSH, and observe the traffic in Wireshark. So here I've launched Wireshark, step 1 complete. So you can see here I've got a bunch of different network connections. I've got a couple of adapters for VirtualBox. I've got a local area connection, that's like my LAN connection, my wired connection, and a local area connection too. Now I have to determine which network adapter is my active adapter right now. And these spark lines right next to the adapters show you a rough estimate of how much traffic is being sent on those network adapters right now. So my VirtualBox adapters are pretty quiet. This local area connection 2, it's dead quiet. That's probably a virtual private network connection. But this local area connection, I can see it's the most active graph. Now, if you're connecting through a laptop, you probably have a Wi-Fi adapter showing up that is probably your most active connection. Your most active connection, that's typically the one you want to capture the traffic on. If I capture traffic on this local area connection 2, I would just see big fat nothing. There's no packets being sent across that adapter. Okay, so I found my active network connection. Now, to use Wireshark, I'm going to just capture without a filter right now. You can just double click on this connection here to start capturing packets. And you can see, holy moly, like every second, you can see the time is in seconds. So in the first second that I started capturing packets, I've captured quite a bit of traffic. So I'm going to click the stop button here. Let's just see. In 1 second, I captured about 52 packets, and I wasn't even doing anything, right? There's just tons of background communication happening on our computers all the time. All the services that are running. There's DNS queries, there's all sorts of stuff going on. The network, you know, all these devices on the network are just communicating all the time. We see ARP request, who has a specific IP address. You know, these devices are all computer. There's just tons and tons of traffic. Lots of it we just simply do not care about, even a little bit. So I can, from File, I can click Close to close this current capture. I'm going to continue without saving. And I'm brought back to that main home screen menu. So if I want to capture a specific type of traffic and ignore all the other packets, I can create a capture filter. So you have to select your adapter first before you enter the filter. I'm going to type TCP port 23. You can see the color, it alternates between pink and green. Pink, or that's a reddish pink, whatever you want to call it. If it's this reddish pink color, that means it's an invalid filter. It's just that my syntax is wrong. If it's green, it means, okay, it's valid, it's a valid filter, we'll be good to go. So now when I double click this adapter, you can see it's not displaying any filters, it's not capturing any packets because none of the packets currently passing through my machine are satisfied by this TCP port 23 filter. So it's only going to capture a packet here if it's using the TCP protocol and it's coming through port 23. So Telnet is a protocol that works over port 23. Oh, we got one. One popped up. Not sure which program's using port 23 there. Something on my machine wants to communicate over port 23 apparently. I could check that source and destination, try to figure out what it is. But let's go down. We are going to use PuTTY. We're not going to use this command line. If you're using Mac OS X or Linux, you could do that, but Windows through PuTTY is the easiest. Let's come down here. I'm going to hide my taskbar, get rid of that. So I've launched PuTTY. I'm going to enter telehack.com in the host name. I'm going to choose Telnet, which will automatically change port 23. You could make it port 23 and then click Telnet, doesn't really matter. Now I'm going to click Open. So watch what happens in Wireshark. All of a sudden I see lots of different packets in Wireshark. And then they stop. So I got to packet number 19 and then got kind of a pause. And then in my PuTTY session, I see a bunch of information here. This, you can experiment with telehack. Essentially what telehack.com is, some people who enjoy keeping the history of the web alive put up a Telnet server here. And this Telnet server, it's a way to just have fun with Telnet, to experiment with it. Telnet is kind of an older, dead-ish protocol, but it's still valid. You can still use it. Here are a bunch of programs that you can run. So let's do, what happened to dice? What's it called? Roll. That's what I'm looking for. I'm going to type ROLL and hit enter. So what's going to happen? I see rolling dice here. It's giving me a random, okay, gave me a 4 and a 1. So if you lose your dice and you're trying to play Settlers of Catan or whatever you're trying to do, you can connect via PuTTY to Telehack and just run the roll program. Impress all your friends. They'll be so impressed. So here we are. It's rolling again. Should be random. All right, there's lots of good stuff on here. Now you've got lots of time on your hands. You can run Star Wars. This is the movie Star Wars in text. So it's fun. So there's some cool stuff that you can do with PuTTY. I'm going to Control-C, get out of there. Now one thing that's interesting, if I type information in here, this is my super secret password, I'm not even going to hit enter. I'm just going to delete all that information. I'm going to change my mind. I don't want to send that with the enter key. All right, that's all I really want to do. I'm going to quit. Connection abort, whatever. Close PuTTY. We don't need you right now. I'm going to stop my capture now. Now we see all these packets in Wireshark, but what can we do with them? So I'm going to show you something fun that you can do. So we've stopped our capture. You can use the stop button or capture stop. It's stopped already, so that option is grayed out. Same with my stop button. Now we are going to pick basically any of these TCP packets. So find something that says TCP. You can right click on it and choose follow TCP stream. Okay, so you should see something similar to the following. What you should notice here is that this is human readable. This just looks like text. This is what my computer was sending to the Telnet server and what the Telnet server was sending back to me. For example, the first thing that I ran the roll program. So I typed R and it sent the R character to the Telnet server. The Telnet server sent an R back to show what should be displayed on my screen. I sent an O, it sent an O back. I sent an L, it sent an L back. I sent another L, it sent another L back. That's why we see this roll, all the characters are duplicated. So the red ones are the ones that I sent. The blue ones are the ones that it sent to me. So you can see the way that the dice rolled and kind of where it ended up. So if you saw the animation on the screen and it ended up with 4 and 1, right? Then I ran roll again. If I scroll down, I got 5 and 4. So what I'm seeing, then I ran Star Wars, right? So I'm seeing kind of a replay of all of my network traffic that I sent to the Telnet server and what it sent me. So if somebody hit the record button, they could record all the text, all these packets, and reconstruct what I was doing. The Star Wars movie, there's a lot of data here. It's a big animation, so it doesn't really show up extremely well. Some people put a lot of time into this. I can scroll down I got to Star Wars. And now here, just the last thing I want to show you in this capture, when I said this is my super secret password, everything I typed got sent across the network. I didn't even have to press the enter key like you normally would on a web page to submit something. So if I had typed a super secret password here, anybody who could capture my network traffic could essentially spy on me. So if you are connecting to Telehack over Wi-Fi, anybody connecting to the same access point as you are could sniff your packets using Wireshark and see everything that you're typing. Let that sink in for a minute. People can essentially spy on you very easily using Wi-Fi because this traffic is not encrypted. So Telnet by default is not encrypted. Web traffic, HTTP traffic, is not encrypted either. So if you're browsing a website and you enter a username and password and that website is not encrypted, people will also be able to see the data that you're sending, including your password. HTTPS traffic is encrypted, and so even if they capture your traffic, they won't be able to see anything. I'm going to come in Wireshark to capture options. There's an option that is enabled by default, so I didn't have to tell you to enable it, but it's enable promiscuous mode on all interfaces. That's an important option and an important concept in capturing traffics and sniffing traffic and hacking and obtaining intelligence. By default, all of our network cards, they only care about the network traffic that originates from our network card and is destined for our network card. They can ignore everything else because a packet that's going to your computer, my network card doesn't have to do anything with it. It's the wrong address, essentially. It's kind of like if the post office just kind of ran all letters by you for your whole neighborhood. You just care about, hopefully, the letters that are intended for you, unless you want to pay other people's bills. With promiscuous mode, you say, I want to inspect all packets, regardless if I'm the intended recipient or not. Now, even if you enable promiscuous mode, your network adapter has to support it. So my Northern Michigan University issued laptop does not support promiscuous mode. I can check that box, but when I start capturing packets, it ignores everybody else's packets anyway. So unfortunately, I can't steal people's Wi-Fi data easily. There are some workarounds, there's some things you can do, but out of the box it's a little bit more challenging. But everybody can inspect their own network traffic. All right, so we've seen what we can do with Telehack. So let's start a new network capture. So I'm going to go File, Close, Continue without saving. Let me show you one thing in Wireshark. We have our local area connection selected with a filter. If I click on a different network adapter, that filter basically disappears. That's why if I type this filter, which is a valid filter, but it's not applied to a network adapter, it just doesn't work. So you always select the network adapter and then apply the filter if you need to. So let's connect. So I'm going to launch PuTTY again. So we are going to connect to sdf.org, and we're not really going to do much of anything on this. So SSH is selected, port 22 is entered, so that's good. So I'm going to click Open. Okay, it takes me to a login. So I'm going to type new. You'll now be connected to new user, make account server. Please log in as new when prompted, so I'm going to put enter. Okay, login. I'm going to type new. So it's public access. I'm the 31st guest today, so not the most popular place in the world to connect to. That's fine. Press your backspace key. Okay, I did that. Please read this carefully. What would I like to use for my login? So I'm going to type super secret guy. Yeah, sure, I agree with your policy. My name. So I'm just going to enter Eduardo. I actually don't want to continue with this. You don't have to create an account on here. Just know I've connected to this server before. The first time that you connect, you'll be met with this message. The server's host key is not cached in the registry. You have no guarantee that the server is the computer you think it is. It gives you a key fingerprint. This is essentially part of the public key. We're using public key, private key encryption to communicate. When you get this message, you want to click yes. You want to accept this key and connect. Go ahead, enter some data. I'm just going to close out of this process. I don't really care about finishing. Oh, except I didn't actually capture any packets in Wireshark. I forgot about that part, so let's go back. Let's start that over. And let's actually do it correctly. So we want to capture TCP port 22. So why port 22? Well, the person who invented SSH emailed the woman in charge of assigning port numbers about, about 25 years ago, more or less, and said, hey, I've got a new protocol. It's better than Telnet. Can I use a port? And she replied back and she said, sure, use port 22. And that's how SSH got port 22 assigned to it. So I'm going to capture TCP port 22 in Wireshark. And I'm going to connect to sdf.org. As soon as I click open, I've got a filter here. I need to clear this filter with the X. Now I can see all the packets. So my display filter should be clear. I've got a bunch of packets here. I'm going to log in as, I'll type new. Let's see. Press the backspace key. Read this carefully. So what username do you want? So I'm going to type something here that I don't want anyone on the internet to know. Super secret 2. Okay, because super secret might already be taken, depending on whether or not they actually recorded my last session. So I'm going to hit enter, and then I'm just going to close this. Again, I don't actually want to register with sdf.org. Close the session. So I'm going to stop my capture. I've captured enough information for this demonstration. Okay, now let's do the same thing that we did for Telnet. So I'm just going to pick, I've got a bunch of TCP stuff here. I'm going to follow TCP stream. And what do I get here? It looks different than Telnet, right? This just looks like a bunch of random garbage. I cannot read this. This is definitely not human readable. No human being on the planet can make sense of this. It's not like the Matrix, where if you just spend enough time looking at the kanji characters, it all starts to make sense. No, this is just Wireshark trying to do its best to render a bunch of random zeros and ones as text. Up at the top, there's a little bit of words that you can read, and this all has to do with the encryption setup. It's basically my computer and the remote computer deciding what encryption that they want to use for the communication. And once they decide what encryption scheme that they want to use, well, everything after that is encrypted. So I sent some data, it sent some data back, I sent some more data, it sent it back, etc., etc. But nobody will be able to decipher what I was doing. So even if a hacker The most elite hacker in the world and I were connected to an access point, even if that hacker is capturing my packets in promiscuous mode and that hacker's wireless card supports promiscuous mode, even if he captures every bit of data that I send across the network, that hacker is going to have no idea what I'm actually typing. And that hacker is going to have no idea what sdf.org, that SSH server, is sending back to me. It can't be broken, essentially. This is extremely secure. SSH is used all the time for communications. This protocol, it's been around for about 25 years, but it's extremely robust, extremely secure. It has been the standard for many years now, and I would anticipate that it's going to be a standard way for communicating in the foreseeable future because its encryption scheme is just good. So this is good. So SSH and Telnet, how are they similar? Well, we use both of these protocols to connect to a remote machine. We got a command line interface, a command prompt where we could run commands and see a bunch of text and run it. So in that way, they're similar. Now, there's one main difference. Describe how SSH and Telnet differences. That should just say how Telnet and SSH differ. There's one key difference. SSH traffic is encrypted. Telnet traffic is plain text. Other difference, Telnet is, we'll say, deprecated. Deprecated means you shouldn't use it unless you really, really have to, where SSH is endorsed. So we've captured traffic in Wireshark using two different filters, and I've showed you how to capture traffic without a filter. You should be able to reconstruct a TCP stream in Wireshark. So you could do the same thing for a web page. You could browse the internet, capture HTTP traffic, and then you could basically reconstruct a web page. So lots of tools out there in the world of computer security capture packets for further analysis. The same way, for example, antivirus checks executables that you download in your email. It's going to scan those for viruses. There are intrusion detection systems and intrusion prevention systems that are constantly analyzing this network traffic, looking for malicious signatures. So lots of security tools are analyzing your network traffic data, looking for bad stuff to try to keep you safe. All right, so as far as a submission for the lab, I want you to follow that TCP stream in Wireshark for the SSH connection and upload that to the course website. I don't need the whole TCP stream. I'm not going to go back and read the whole thing. I just want to see that you've got it captured. All right, that's it. So have fun with Wireshark. You know, go to a public space, go to an open area of the public library, see what you can capture. Can you capture somebody else's network traffic? With not doing anything malicious. Like, can you just observe the packets flowing across the network? What can you see? Your wireless card may not be able to support it, so try to figure out if it does or if it doesn't. So look at the source and destinations, compare that to your IP address and IP config, see if that matches. Google the destination IP addresses, just do some investigation. In Wireshark, you can explore the whole OSI model. Here we've got this, maybe I should say the TCP IP model, because here we've got the SSH protocol. This is essentially the session, presentation, and application layer all being managed by PuTTY. We've got the layer 4 TCP, we've got layer 3 Internet Protocol, we've got our layer 2, our Ethernet layer, and then layer 1 is just the physical. So we're not, PuTTY doesn't actually, it can't show me the physical connection. It's not going to show me the physical wire that's carrying the signal. but we can investigate what's actually happening here. So take some time, expand these packets in Wireshark, see what you can find, see what you've learned about protocols, what you've learned about Ethernet, about Internet Protocol, about routing, about local area networks, all that stuff. See what you can find in Wireshark. Do some investigation. All right, Wireshark's fun. Every competent network administrator knows what Wireshark is, how to use it. So spend some time to learn it.